Everyone. This is the part 2 of the linear regression with R series. In the previous post, we have fitted a linear regression model using all of the variables in our data set to predict the response variable lead. Even though our model has a very large R square of 0.96, many of our predictors were not significant. So in this section, we're going to select the top predictors without losing too much of the model's predictability. In order to do this, we're going to use model selection method of best subset, forward and backward in the package leaps. Let's first start by loading the previous model into our console. So we load the library leaps as well as SP, that's where the dataset resides. And let's build the model benchmark by calling the LM function. And this is a summary of our linear model using all of the predictors. And from inspecting the top 6 observations in our dataset using the function head, we have found that column 11 to 14 are stored as factors. So these are the categorical variables. Let's convert these factors into numeric or dummy variables for later analysis. This would help us build the model that we want to use for the subset selections. Part 1 is the best subset selection. It compares all the possible models using a specific set of predictors and display the best fitting model that contain 1 predictors, 2 predictors, and so on. Let's begin by building a complete model with all the predictors. Before using rig subset, that's the function that we're going to call if we want to use best subset selection. Let's convert all the categorical variables into dummies that we have done in this part. The function that you want to use for best subset selection is rig subsets. And by doing that, we're going to separate the predicted variables into X and the outcome into Y. We do that by selecting only the columns that we want. Remember, the method should be exhaustive if we want to do best subset. And we set the number of maximum variables to the dimension of variables, which is 13. And then we output the summary based on the best subset selection. I would like to direct your attention to this section. This is the result that we want. How do we interpret this graph? If we want to select one variable, we are going to look at the variable with a star indicating here. This means that if we want to select one variable in our final linear model, we're going to select zinc. If we want to select 2, we're going to select cadmium and zinc, so on and so forth. We can see that in the last column where we use the full model, we're going to select all of the predictors. This will give us the same linear model as the one we have gotten in the previous section. But how do we know how many variables we want in our final model? There are 3 criteria for a selection. First is called BIC, second, CP, and third, adjusted R square. This will all tell us the amount of predictability a model can give us, considering how many predictors it has. For example, if we add more predictors without increasing too much of the predictability, the BIC would increase and the adjusted R square would decrease, which both indicate that our adding of this additional predictor is not a wise choice. Let's plot the BIC given the different number of predictors we have in our model. Here we have a trend of the BIC, with respect to how many variables we have in our model. As we can see, the BIC reaches the minimum at 5. That means we can achieve the best predictability given 5 number of predictors here. And adding more predictors will not necessarily increase our model's predictability. Similarly, CP also has produce the best model at 5 predictors. If we look at adjusted R-square, this is different from CP and BIC in that we want to achieve the maximum adjusted R-square. We can see that it sort of plateaus after it reaches 5 predictors. So based on BIC and CP, we will select a model with 5 variables. But according to adjusted R-square, we will select a model with 9 variables here. However, a closer inspection of the graph reveals that adjusted R-square reaches a plateau after 5 variables. So we still select the top 5 and construct a new linear model. So now we have selected the best 5 variables based on the best subset output. We build the model again. So in the above summary, we can see that all our variables are significant. So these are the 5 that we selected are among the top 5 in our best subset selection. We can see that because they all have at least 2 stars indicating their significance here. Moreover, our R-square now is 0.95. It's not a significant drop from our previous model of 0.96, but we have significantly reduced the number of variables in our model. This could increase the interpretability as well as make our model more concise and efficient. Besides best subset, there are 2 more subset selection methods in the function rig subset. One is called forward selection, and the other is backward stepwise selection. We build a model similarly to what we did with best subset, except we specify here the method equals forward to indicate we want forward selection. And we can interpret this plot similarly to what we did with rig subset. And we can see that forward selection also selected 5 variables based on BIC, CP, and adjusted R-square. And another model selection method is called backward stepwise. And it works similarly to forward stepwise, except we indicate here method equals backward. This will give us very similar plots as we have gotten from forward stepwise. So now we have gotten the result that 5 variables produce the best result. However, do we choose the same 5 variables based on the 3 methods? Rig's best subset selection, forward stepwise, and backward stepwise? Let's compare. So this is the for loop I wrote that would extract the variables that has a star indicating there. In the model, out 2, out 3, and out 1. And we can see that all of the 3 models selected the same 5 variables. This means that ideally we are going to use the 5 variables: cadmium, zinc, OM, FFREQ, and line for building our final linear model. Thank you.